All right, today we're diving into the mind of Hermann Weyl. He was a mathematician, but he was wrestling with a question that's almost, well, philosophical. What's the connection between the truth that science uncovers and the beauty that we feel when we look at the world? For him, the answer came down to a single, powerful idea: symmetry.
So let's jump right in. To really get Weyl, you've got to understand the world he was living in. It's 1919, World War I has just shattered Europe. So for him, science wasn't just some abstract exercise. It was a search for something solid, something permanent, a harmony of the world, as he put it, that couldn't be torn apart by war. And that search, that deep need for order, is what would drive his entire life's work. And that brings us right to our first section, this quest for harmony. This wasn't just a hobby for him, it was the absolute core of his work. And at the very heart of that quest was one single idea: symmetry. But right away, Weyl hit a major roadblock. And the problem, surprisingly, was the word symmetry itself. He realized that people were using it to mean two totally different, almost opposite things. Before he could build a bridge between truth and beauty, he had to figure out these two faces of symmetry. This slide just lays out the dilemma perfectly. On the one hand, you have the classical idea of symmetry, the ancient Greek concept of harmonia. It's a feeling, an aesthetic sense that something is well proportioned. But on the other hand, you've got the modern scientific definition, and that's not a feeling at all. It's a very precise black and white test. A shape is symmetric if it stays exactly the same after you do something to it, like reflected in a mirror. One's subjective, the other's totally objective. And here it is. This is the central question that drove Weyl's work. How in the world do you connect those two things? How does a vague, subjective feeling of beauty relate to a cold, hard, objective test about whether a shape changes when you rotate it? Which brings us to Weyl's absolutely brilliant solution. See, he didn't want to just toss out that old, fuzzy idea of harmony. No, he wanted to refine it, to sharpen it into a tool that was both incredibly beautiful and scientifically powerful. And this is how he did it. It's this beautiful three-step method. First, you start with that big, intuitive, kind of vague idea, like harmony. Second, you drill down and find a super specific, concrete example you can actually get your hands on, like simple mirror symmetry. And then the third step, the genius part, is you use the rigor of mathematics to build back up to a new, general, and incredibly powerful principle. It's literally a method for turning a feeling into a scientific law. And here's the result of that process. Now, I know this definition looks a bit intimidating, but trust me, the core idea is actually pretty simple. That phrase, a group of automorphic transformations, that's just a fancy way of saying all the different ways you can mess with an object without changing what it is. Think of a square, right? You can rotate it, you can flip it, and it's still a square. For Weyl, this was everything. Suddenly, perfection wasn't a vague feeling anymore. It was a number. The more ways you could transform an object and have it stay the same, the more symmetric, and in his view, the more perfect it was. That was the bridge he'd been looking for. So this brings us to the real climax of Weyl's whole quest. Because now that he had this precise, powerful definition of symmetry, he proposed something truly radical: that this concept of beauty could actually be a guide to finding scientific truth. This is maybe his most famous quote, and for a scientist, it's just a stunning thing to say. He's basically admitting that when the path forward was unclear, his fundamental guiding principle was an aesthetic one. And that should really make you stop and think, right? Isn't science supposed to be about the cold, hard facts? About choosing what's true, even if it's messy or ugly? What on earth could he mean by choosing the beautiful? And here's the key. For Weyl, raw experimental data could sometimes be misleading. He was making a bet, a huge bet, that the most elegant, the most symmetric theory would ultimately point toward a deeper, more fundamental truth, one that would make sense of all the messy data later on. So for him, beauty wasn't just a nice result of finding the truth. It was the flashlight you used to find it in the dark. And the truly amazing thing is just how incredibly successful this idea turned out to be. Weyl's refined concept of symmetry wasn't just some abstract mathematical game. It turned out to be a unifying principle that you could see, well, everywhere. I mean, just look at this. The same principle explains the perfection of a sphere in geometry and the fundamental laws of Einstein's relativity and the standard model of particle physics. We see the exact same mathematical signature at work in the six-fold pattern of a snowflake and in the hexagons of a honeycomb. And of course, it's the very same principle that human beings have used for thousands of years to create order and beauty, in everything from Greek temples to Islamic art. It's all connected.
So let's bring it all home and circle back to where we began, with Weyl's profound search for the universe's hidden order and what that might mean for us. Weyl's entire life's work really feels like an echo of this ancient quote from the Greek philosopher Heraclitus. The idea is simple but powerful, that underneath all the chaos and noise we see on the surface, there's a deeper, more profound, and more beautiful order. Weyl's great achievement was to take that ancient intuition and give it the precise language of modern mathematics. And that's really the ultimate takeaway here. Symmetry is that bridge. It's the meeting point. It's the place where the objective, rational structure of the universe, the true, and our own subjective, deeply felt sense of harmony, the beautiful, finally click together and become the same thing. Which leaves us with a pretty mind-bending question to ponder. Is our attraction to things that are beautiful and symmetric just some random quirk of human psychology? Or could it be something much, much deeper? Could it be, as Weyl seemed to believe, a kind of resonance, a sign that our minds are, in some fundamental way, tuned to the deep, hidden, mathematical harmony of the cosmos itself?